Hello everyone, today we are going to solve today's daily lead code problem, problem number 2463, minimum total distance traveled. So let's read the problem statement. There are some robots and factories on the x-axis. You are given an integer array robot where robot I is the position of the ith robot, and you are also given a 2D integer array factory where factory j is basically position of j and limit of j. Indicates that position of j is the position of the jth factory and that the jth factory can repair at most limit of j robots. Okay, the position of each robot are unique. The position of each factory are also unique. Note that a robot can be in the same position as a factory initially. Okay, all the robots are initially broken. They keep moving in one direction. The direction could be the negative or positive direction of the x-axis. When a robot reaches a factory that did not reach its limit, the factory repairs the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Okay. Return the minimum total distance traveled by all the robots. The test cases are generated that all robot can be repaired. Okay. All robot moves at the same speed. If two robot moves in the same direction, they will never collide. Opposite direction, they meet at some point, they do not collide, they cross each other. If a robot passes by a factory that reaches its limit, it cross. Okay, so basically the problem statement is simple, that there are some robot and we are given its position, and also there are some factory. We know the position of each factory and the limit, like at most how many robot can be repaired at that factory. So we have to move the robot to the any of the factory for repair, and so that the total distance traveled by all the robot are minimum. Okay, so we have to find like how we can solve this basically. mm, it's first of all we need to like sort the position to, like, whenever you are given a position in one direction, uh, like one dimensional position, then you can sort them and make some greedy move. But would greedy work here? Like greedy won't work, no. Basically, if we are simply asked that is it possible to distribute in some way that all robot can be repaired, like a boolean answer yes or no, then I think we can solve it is greedily. But here we have to calculate the minimum total distance, so I think we have to use dynamic programming here. uh, Basically, a robot has choice. Robot can go to any of the factories. What is the constant? Let's check out. Constant is 100, so yeah, we can form a DP here. Okay. So what we can do here, like we will take a 3D DP. Like what is our idea? Like we will have DP of I comma j comma k. So what is the definition of this? Like dp of I comma j comma k is basically uh, minimum distance, minimum distance traveled by the robots if we consider first I robot and j factories. Like first I robot and j factories mean like after we sort robot and factories uh, with the coordinates, on the basis of the coordinate, then the first I robot and j factories. And what is k there? Like first I robot and j factories, and uh, and in the last factory, and in the last factory there are k robots. So basically minimum distance dp of ijk mean minimum distance traveled by the robot if we consider only like first I robot and j factories, and we know that in the last factory there are k robots already. K robots. So now first we declare like I'm using I64 as long so that I have to type less. Now let's take infinity also 40 and dp table like dp. What will be the dimension ijk? I can go up to 100, j can go up to 100, k also can go up to 100. Okay, so let's take as 100 one. Now here we first sort the robot. Mm, Sorry. Then sort the factories also. Now let's initialize dp with -1, and we will simply return calculate like robot dot size -1, factory dot size -1. Let's write the calculate function here. It will take I, j, k, and let range robot, comma, method in factory. Okay. Now in the calculate function, like initially we are considering like we have to calculate all the robot, all the factory, and initially last factory has 0 robots, and simply we pass robot and factory, right? So now we have to write the base case like if we have no robot like I less than 0, that means basically here I is the index of the last robot we are considering and j is the last index of the factory we are considering. So if I less than 0 means we don't have any robots, so the distance covered by them will be obviously 0. And if j is less than 0 means we don't have factory, but we definitely have some robot. So it is impossible. So we'll return infinity. Like we can't repair that robot. Now the memoization part, like if this dp state is already calculated, like dp of ijk is not equal to -1, we will simply return the dp state like simple memoization technique. Now we have just two choice. We are uh, we are focusing on the last robot. So the last robot have two choices. Like it can go either to the last factory we are considering. Like we are considering the ith robot and the jth factory as the last. So the ith robot can go either to the jth factory or it can go uh, any of the factories previous to it. So option one, like if it does not go to jth factory. If it does not go to jth factory, what does that mean? That mean it will go in the other factory. So for that case, other equal to what will be? We will simply calculate like now the I is the basically the last robot because it does not go to the jth factory, and j minus 1 will be the last factory because it won't go to the jth factory, so it will go definitely to any of the factory previous to it. And what will be number of robot in that factory will be 0 because no robot has still there, and we will simply pass robot comma factory. Okay. And another case, like if here ith if ith robot does not go to the jth factory, and here it will be if ith robot go to the jth factory, then what will happen? Like if it go to the current factory, then simply it will be like we will calculate, like we have already passed like the ith robot to the jth factory. So for that, what will be cost? Cost will be, so to move ith robot to the jth factory, the cost will be simply abs of the position of the ith robot and the position of the jth factory. So position of the ith robot is simply robot of I, and position of the jth factory is factory of j comma 0. Yeah. And the ith robot already goes to the jth factory. Now we have I minus 1 robot left, and we have still j factories. And if like in the jth factory, we know that there are already k robots are there, so now ith robot also goes to the j factory. So now the robot count will increase by 1, and we will return minimum of, like we have to also minimum of current comma other, and we have to store this answer in the dp of I comma j comma k. And here also one thing we have, like here we does not like have not checked that if the limit has already over or not. Like we have to check, like is it possible to repair the ith robot in the jth factory. So for that, what we can do, we have to check like if k is less than the limit or not. Like if the k means here, like k robots are already in the jth factory, so if it is less than the limit, we can send another robot to it, otherwise we can't do it. So for that, we have to just check if k is less than the limit of the jth factory, which is factory of j comma 1. Then we can send and get the answer, or if otherwise we can't do it, so we will simply return infinity. So I think it should work. Let's run it. Yeah, it passed on the sample, so I think everything looks fine. So let's run this on the actual test cases. And yeah, it got accepted. So basically what we have done, we have basically take a DP table here. We have sort robot and factory by their position. Initialized all the DP to -1, like basically sim basic memoization technique. Then what is the definition of like calculate of I, J and K? Like we are now considering ith robot as the last, jth factory as the last, and we know that jth factory has k robot already in there. So it will return the minimum distance for that scenario. So if I less than 0 means there are no robot left. So if there is no robot left, then the distance covered by them will be 0. J less than 0 means there is no factory left, but definitely there is robot. If there is no robot, then it will uh, simply would return 0. Na? There is a robot, but there is no factory. So in that case, we will return infinity because that is like not possible. And in the memoization, like if we already have calculated it, we will simply return this. And now the last robot has two choice, like either it go to the last factory or go in the previous any of the previous one. So if it does not go to the jth factory means we will simply ignore the j factory. We still have I throughput. We will consider up to j minus 1 factory and it has 0 robot initially. And if I throughput go to the jth factory, then we have to just check that we can send it to the jth factory or not. For that we have to check like if k is less than factory, k means the robot already there, and if it is less than the limit we can send another robot. So for that the cost will be the position of robot and the position of factory absolute distance, plus we have to now calculate like I minus 1 robots, and we still have j factory, and the count of the robot in the jth factory will be k plus 1. So otherwise we will return infinity if it reaches the its limit. And lastly we will simply return the minimum of these two choices. So what is the time complexity of this? Like in the memoization we simply know like the time complexity is like here is like if the size of the robot is n and size of the factory is m, then it is n log n. This will be m log m. And now the state of the like dp, so state will be like here it is 100 cross 100 cross 100 mean 10 to the power 6 nearly about it will pass. The time complexity will be simply m square n, like the square of this, because it is contributing two states, position and the limit, and the robot or state. So m square n will be the time complexity, which will got passed because the constraint is low here for that reason. So that's all for today. Thank you.